Now, the theorem 6.7, that is, if a perpendicular, if a perpendicular is drawn from the vertex of from the vertex of of the the right angle of a right angle triangle of the right angle of the right angle triangle, a right angle triangle to the hypotenuse, then triangle on both sides of perpendicular of the perpendicular are similar to whole triangle to whole triangle and to each other and to each other. That is, we have to prove, that is, if we have taken a right angle triangle, let a right angle triangle be this way. We have constructed a right angle triangle, as you can see. That is ABC, if A, B, and C is given. And it is right angle triangle here, that is at the point B, at vertex B. So if a perpendicular drawn from the vertex of the right angle of a right angle triangle to the hypotenuse, we have drawn a perpendicular from that is right angle to the hypotenuse, then the triangle on the both sides of the perpendicular are similar. So let it is the D. So two triangles formed, that is ABD and DBC are the two triangles. So in this theorem, it is said that these two triangles are similar, and these two triangles are similar to the triangle ABC also. So we have to prove. Now let as we can see that in triangle ABD, in a triangle ABD as ABD, and in triangle ABC, we have angle A in both triangle, angle A equal to angle A. That is this is the corner for the triangle, and this is triangle corner for triangle ABD also. Now D is equal to B. Here ABD. So in triangle ABD, we have got D is equal to angle B of triangle ABC. So this is 90 degree, this is 90 degree. So it is angle B. So triangle ABD, sorry, is similar to triangle ABC by AA criteria of similarity. Now, for the in triangle that is DBC, sorry, DBC, this triangle and triangle ABC, and in triangle ABC, we have that is angle C equal to, that is DBC, and this corner is also for the triangle ABC, and it is same angle for the triangle ABC and DBC. So angle C equal to angle C. This is corner for triangle DBC, and this is also corner for triangle ABC. So angle C equal to angle C. Now angle D for DBC is 90 degree, and it is also for angle B is 90 degree. So both the triangles, that is triangle DBC and ABC, are similar. So triangle DBC, so triangle, we can write down, so triangle DBC, that is DBC, is similar to triangle ABC. Now we can put here 1, it is 2 by AA criteria, it is 2. Now from 1 and 2, what we can see, that is from 1 and 2, from 1 and 2, that is as triangle DBC is similar to ABC, and triangle ADB is similar to ABC. So triangle that is ABD is similar triangle. That is ABD is similar to triangle. You can see similar to triangle DB. So in this way we have proved that is these two triangles are similar, and they are also similar to triangle A, B, and C. So the Pythagoras theorem number 6.7, if a perpendicular is drawn, एक कभी perpendicular drawn किया जाता है right angle of the right angle triangle, right angle से hypotenuse, देन ये दो ट्रायंगल में डिवाइड कर देता है, दो ट्रायंगल में सेपरेट करता है ट्रायंगल एबीसी को, तो दोनों ट्रायंगल जो फॉर्म हुआ है ए बी डी और डी बी सी, ये दोनों सिमिलर हो जाते हैं अपने में। और दूसरा ये होता है कि ये ट्रायंगल ए डी बी और डी बी सी जो है सिमिलर होता है ए बी सी से। तो ये दिया हुआ है थ्योरम 6.7। कोई प्रॉब्लम इसमें? एनी प्रॉब्लम?
नो सर।
ना थ्योरम नंबर हम दूसरा देखते हैं, दैट इज 6.8। Now theorem number 6.8 we have to solve. Now theorem 6.8. It is given in a right triangle, the square of hypotenuse equal to the sum of square of other two sides. So in a right angle triangle, in a right triangle. The square of the hypotenuse of the hypotenuse is equal to the sum of the square of 1 of the other two sides of the other two sides. In a right angle triangle, the square of hypotenuse is equal to the sum of square of other two sides. So same way, we construct a right angle triangle as we have constructed early one. That is in this way. Now it is B, A, C. Now it is D. So it is right angle D. Now, as these two triangles are similar, as we have proved in the section that is in theorem 6.7, so triangle AB, ADB is similar to, as we can write down, as triangle ABD, ABD is similar to triangle ABC. हम लिख सकते हैं ट्रायंगल जो है परपेंडिकुलर तो ड्रॉ किए हैं हम लोग वी हैव ड्रॉ लेट वी हैव ड्रॉ द परपेंडिकुलर इसको लिख भी दिए थे so as we have drawn let यहाँ से शुरू कर देता हूँ let us draw perpendicular that is uh, BD perpendicular to AC ये ड्रॉ की देन हम इसको थ्योरम प्रूव किए हुए हैं उसके आधार पे हम लिख सकते हैं क्या ADB is similar to ABD is similar to ABC. So ABC we have written. So ADB I will write down ADB. So if we take AD in triangle ADB, so AD by AB we can put here AD by AB. That is, it is the base for this triangle. Now, if we take AB again, AB for the hypotenuse for the ADB, hypotenuse for the ADB. So we have taken hypotenuse AB. Then we have to put the hypotenuse of the ABC. So AC is hypotenuse. So we can write down that is the AB square equal to AD dot AC. Right? Now similarly, in second one, VD perpendicular to ABC. Now in triangle, that is BDC, BDC and ABC. ABC we have, that is DC. We will put perpendicular side D on DC. So DC, this side DC will equal to that is the other side DC. This time the base is this one, so the base for this one is the second one equal to hypotenuse. That is, if we put the BC by BC for the hypotenuse one, this one, then we have to put the hypotenuse AC again. That is AC. So we will get BC square equal to, that is DC dot AC. Second, a second one was now adding 1 and 2, we will add these two. Uh, we can write down here. This is second one, first one. So adding both 1 and 2, adding 1 and 2, दोनों को जोड़ देंगे, then what we'll get, that is AB square plus BC square equal to, that is AB AC, AB dot AC plus that is BC plus AC. Now we will get AB square plus BC square. We will take common AC as common, or AD plus BC. Here AD plus BC. So AD plus BC equal to AC, or we will get AB square plus BC square equal to AC dot, we can put here, that is AB plus BC equal to, it will be AC. So if we can write down AC square equal to AB square plus BC. So the right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. So as you can see here, it is proved. In this way, we have proved the second theorem. Any problem? Any problem?
No, sir.
No.
No, sir.
All right.
No problem, sir. No,
Okay,
sir.
now 6.9. Theorem 6.9. We will prove the 6.9. Theorem is given there. 6.9. Now, theorem is 6.9. In a trend, we have to prove 6.9. In a trend, if square of one, if square of one side of one side is equal to the equal to the sum of the square of the other two sides, then the angle opposite to first side, the first side is a right angle. Is a right. Here, the theorem is given a triangle if the square of one side is equal to the sum of the square of the other two sides, then the angle opposite to the first side, that is, we have to prove that Pythagoras theorem, that is, if a square equal to, that is, a hypotenuse is given, that is, AC square equal to AB square plus BC square, then we have to prove that that is a right angle triangle. Let triangles are here. We have taken a right angle triangle. Not it is not right angle, a triangle. I have taken a triangle, ABC triangle, in which it is given that the square of one side is equal to sum of the square of other two sides. So square of one side, AC square, given square of one side, that is AB square, that is sorry, square of one side, that AC square equal to AB square plus BC square. It is given. So we have to prove that this is it. To prove that is, we can write down to prove that prove that angle. So we have to prove that is B is 90 degrees. So let's construct another triangle here. PQR, PQ and R, in which uh, we have taken it as right angle. So construct, I'm writing here. Let us let us construct a right angle triangle P PQR, in which angle Q equal to 90 and PQ, that is PQ equal to, we can construct the PQ equal to AB and PQ equal to AB and QR, that is QR equal to this. Yeah, PQ equal to AB and BQ in figure, it is not clear that is they are equal, but I am drawing it equal in shape as we have taken equal side. So a triangle, this is ABC, in which is given AC square equal to AB square plus BC square. Then we have to prove that angle B is 90. So I am taking another triangle of in which their length, that is AB equal to PQ, PQ and R, in which Q angle Q equal to 90 degrees. So, and we have taken QR equal to BC. So by Pythagoras theorem, we can write down by Pythagoras theorem as it is right angle triangle. So we can write down. So by Pythagoras theorem, we can write down P uh, PR square, PR square, PR square equal to, that is PQ square plus RQ square. PQ square equal to RQ square. So at the place of PQ and RQ, we can put PR square equal to AB square plus BC square. We can put, as we have taken, that is these two constructed, that is the PQ equal to QR. So we can write down PQ PR square equal to AB square plus BC square. Or for this two, it is given that is given, that is the AB square plus BC square equal to AC square. So PR square equal to, we can write down AC square or PR equal to AC. Now this side is equal to this side from here. Now in triangle ABC and PQR, in triangle ABC and PQR, triangle PQR, QR, that is the ABC, we have taken ABC. So AB equal to PQR constructed. हम लोग constructed that is the BC equal to Q1 constructed. Now that is AC equal to Q1, AC equal to, sorry, AC equal to PR proved, that is in one from one from one proof. Okay. So triangle AC, that is ABC, sorry, PQR, ABC, sorry, ABC and ABC is congruent to triangle PQR, congruent to triangle PQ. So these two triangles are congruent, equal size square. So we can write down angle B equal to angle Q equal to 90 degrees by CP. So in this way, we have proved that is angle B is 90 degrees. So the right, and that is angle opposite to the first side is right angle. The opposite to the first side, this side is first side. So it is a 90 degree here. B is a 90 degree. So in this way, we have to prove the theorem. So any problem? Any
No,
problem?
No, sir.
All right. So today class is over. Thank you
no,
for
sir.